Assalamualaikum warahmatullahi wabarakatuh. My name is CHM561 binti Khairuddin. Recently, I presented to you guys about the consequences when not implement the instrument calibration. So, in this video, I will explain the role of instrument calibration in total quality management for pharmaceutical quality control laboratories. But before that, I will shortly brief the introduction regarding TQM. So, what is TQM? TQM is a systematic quality management approach that focuses on continuous improvement, customer satisfaction, prevention of defects, and ensuring consistency in processes and outputs. Therefore, TQM can be summarized as a management system for a customer-focused organization that engages all employees in continual improvement for the organization. It is an integrative system that uses strategy, data, and effective communication to integrate quality discipline into processes, product, service, and quality of the organization. What about TQM in the pharmaceutical industry? TQM plays an important role in the pharmaceutical industry by ensuring product quality and patient safety throughout the drug life cycle. In pharmaceutical quality control laboratories, TQM ensures that analytical results are accurate, reliable, and comply with the regulatory standards. In this part, I will explain about the instrument calibration in pharmaceutical laboratories. Instrument calibration involves comparing an instrument's measurements with a non-reference standard to detect and correct any deviations. In the pharmaceutical industry is governed by strict regulatory requirements and best practices aimed at ensuring the accuracy and reliability of measurements. By adhering to these standards, pharmaceutical companies can maintain product quality, ensure patient safety, and comply with regulatory expectations. Regular calibration not only supports compliance but also builds confidence in the reliability of test results and manufacturing processes. Now, we move on to the role of instrument calibration, which is to ensure measurement accuracy. Firstly, it ensures that all laboratory instruments produce accurate and reliable data, allowing laboratories to obtain trustworthy analytical results. Secondly, it reduces variability in analytical results during laboratory testing procedures, so repeated tests can produce more consistent outcomes. In addition, calibration helps prevent systematic and random errors that may affect analytical measurements and testing. Finally, it supports consistency in quality control testing and daily laboratory operations, helping laboratories maintain high standards of performance and reliability. On calibration-based control of analytical instrument performance, the laboratories should implement daily, weekly, and monthly routine calibration schedules to ensure that instruments are regularly monitored and continue to function accurately over time. Next, regular verification is performed before analytical testing to confirm that the instruments are properly operated and are suitable to be used. In addition, calibration ensures that laboratory instruments remain within acceptable operational and quality limits. Finally, certified standard reference materials are used during calibration procedures as benchmarks to compare and validate instrument readings. The third key point focuses on the detection and prevention of analytical errors through calibration systems. First, the calibrations can identify inaccurate instrument reading before any analysis is carried out. Therefore, any potential problems can be detected early. Second, it can prevent false positive and false negative results that can lead to incorrect analytical interpretations and decisions. In addition, calibration also can reduce repeated analysis, rework, and also sample rejection, which can save time and improve the laboratory efficiency. Lastly, it also can improve the consistency of the data produced by the laboratory, ensuring that the results are reliable and can be trusted. Here, I want to explain a little bit regarding false positive and false negative. False positive occurs when a test incorrectly indicates a condition is present, while a false negative occurs when a test incorrectly indicates a condition is absent. Next, we focus on the use of calibration data to improve laboratory quality. Calibration records help laboratories monitor instrument performance, identify trends, and detect potential issues early. They also support decisions on instrument maintenance or replacement. Overall, calibration data also contributes to continuous improvement through the PDCA cycle. In conclusion, instrument calibration is essential to ensure accuracy, reliability, continuous improvement, and patient safety in pharmaceutical quality control laboratories.